Okay, so let's debug a memory issue live, and to do that and to demonstrate how we can do it, we can use this repository. It's a repository I created for with this goal, so with the goal to understand how we can detect out of memory issues. And you can find it on GitHub. The name is Rosilla, which is my username, and then demo OOM, which stands for out of memory. So the repository exposes some endpoints, and trust me, some of those endpoints have a memory issue. But how to detect it? Well, first of all, we can very easily start the activity monitor for our operating system. So we will just do that. And on one side, we start the application. We also start the activity monitor and filter by node. And then to really have a better understanding of what's going on, we need to simulate traffic peak in our service. So we will use the stress command. Let's have a look here. We can see that there is another process, another node process, because basically this is the process that run the stress test. So after some time should go out. Yes, exactly. And we can see that we had a spike in memory. So we started from it was around 20-30 megabytes to now more than 500 megabytes. So this means we have a memory leak. How to detect what's causing that? Well, we can leverage the inspect option of node. So let's just do that. Let's start node with the inspect option. And then we can go to the Chrome inspect devices tab. So let me open it on another tab so that we can see it on this screen. Yes, I can see that my process is ready to be inspected here. So I can run inspect, and then I can start the memory heap profiling. So let's run the stress test again. Okay, we can stop the memory profiling debug, and we can see that we have a really interesting result, because it seems that this function total list from the utils.js file is consuming more than 400 megabytes of memory, which for such a simple application it's absolutely too much. Let's try to understand why. And if we go here, we can see the total list, which is called by the list endpoint. So list endpoint get a size as a query and then call total list. Well, we can see that we keep pushing to an array. This array is never cleaned up, so the length and the data inside this array will continuously grow up, and that's why we're causing a memory leak. Now we can basically fix it by just doing that. And now we can try to analyze the app again. So we can run the start command, open as first the activity monitor. We can see that we are around 30 megabytes. We can run the stress test. So previously we were around 500 megabytes after the stress test, and now, well, results seems to be way better. So the other process is gone, which was, as we said before, the stress test. Now we are around 30 megabytes, which is super good. It means memory consumption is now steady. And similar thing, so if we go here, let's close this. We don't have any remote target right now because we have not started to inspect our app yet. So let's do that. Let's inspect the app and start the heap profiling and run the stress test again. Nice. We can stop it. And now you can see that the total list function from utils is no longer in the top functions occupy more memory. We have this internal next tick Node.js function using around 200 kilobytes, which is absolutely fine. Let's also remind that we are running a stress test. We are running thousands and thousands of requests against those endpoints, so it's completely fine. We have some internal Node.js function using some memory, but yeah, we definitely fixed the memory issue. And another great tool we can also double check is the flame graph profiling. In more general, let's say that the profiling is not something that will just focus on memory leak per se. So if you only want to find a memory leak, I recommend to use the other tools mentioned before. But if you have a performance bottleneck, maybe you are stuck or you are blocking the Node.js event loop, maybe you are using too much CPU, well, this is a great tool to use, so I will also show this tool to you. So let's see how it works. In normal conditions, so we will start to profile our app and again to run the stress test. And once we complete it, we will stop the profiling and the new tab will be opened. And this is what happens in normal conditions. So yeah, we have some function using some memory, but that's not super high. Let's compare it to our previous version. So let's just use the previous code that was causing a memory leak, running the profile again, running the stress test, stop the profiling, and we can now see some differences. So we now have this function that is outputted multiple times. So we have total list here and there. And again, from here we can see that this function is basically a function where the Node.js process is stuck for some time. So this is probably a performance issue problem. And in this specific case, it was identified not really for the memory consumption, but more because we are doing a for loop. And of course, Node.js needs some time for the CPU to process this for loop. So again, if we compare it to the other graph, we can see that we have more spikes here, and we can see that we have the total list function again as the root cause for the performance issue. So yeah, we've seen how to identify a memory leak problem and also how to do a flame graph profiling, which is super cool to understand if we have a performance bottleneck and to fix it. Feel free to have a more deeper look in my repo. Feel free to follow me and to follow my open source work in GitHub, and see you soon.